x, then calculate the area of the isosceles triangle below. Now this is the isosceles triangle. For isosceles triangle, two sides are the same. This is the meaning of same sides here, and we have triangle ABC. Therefore, AC is equals to BC. Now if they're equal, it's easier to get the value for x. We simply equate these two sides that are the same. So let's move on. We have our solution here. So we can start with this side, saying 2x minus 1 equals x plus 2. And here we can collect like terms. So bringing x to the left hand side, we have here 2x minus x equals, you are left with 2 from the left hand side, and also bring negative 1 to the right hand side, changing to positive 1. Then simplifying the left hand side, 2x minus x, we get x, and we equate it to 2 plus 1 is 3. So this is the solution for the value for x. Now since we've already gotten the value for x, then we need to know the side. So we are free to take any, either this side or the other one. Since they're the same, it will give the same solution. So we have here 3, replacing x, making 5. Therefore, the whole distance here is 5. Now let's show our working here by saying x plus 2 is the same as replacing x by 3 plus 2. We get 5, and that is this side here, and also likewise the same side here. Now the next part is saying then calculate the area of the isosceles triangle below. So the next thing is to calculate the area. Firstly, we can redraw the diagram just that is near us. So let me go ahead and do that. There are two ways in which we can get the area of this triangle ABC. The first method is using Heron's formula. And the second method is, of course, we need to get the height of this triangle, because we had some line which was drawn from here like that, making a right angle, so we can get the height h, and we use the base, that means the height, and we get the half of it to also get the same area of this isosceles triangle. Now let me use the Heron's formula first. So method number 1 is using Heron's formula. We'll have area is given by square root of s into s minus a. We multiply by s minus b, and we multiply by s minus c, where s is estimate perimeter. Perimeter is the distance around the figure, so we can get the value for s first, and we have our s as the sides 6 plus 5 plus 5 also, semi, meaning half of, so we're dividing this by 2. Therefore our value for s is the addition of all these three numbers, and that is 16 over 2. So when we divide 16 by 2, we will obtain 8, and of course the measurements were all in centimeter. So after that, we can move on and start substituting to our formula here. Area A is given by the square root of our 8 multiplies by 8 minus A, and A is one of the sides facing the angle A, so that is 5. Then we multiply this by 8 minus the next 5, that is B, and lastly 8 minus the next side here 6. So let's close up this, and after that we can go ahead and simplify. Square root of 8, so 8 minus 5 we get 3, and also this one is the same as 3. 8 minus 6 we get 2 here, and we will have to multiply all these numbers together. 2 times 3 we get 6 times 3, that is 18. 18 times 8 is 144. Therefore our A equals to square root of 144. Therefore the root of 144 is 12. So our answer is 12 square centimeter. and that is the first method using Heron's formula. Let's again go ahead and use the other approach. Now the next approach is what we know using half base height, and let's redraw the diagram here. Remember we put something like that, and in the middle here, since it is an isosceles triangle, then the line divides AB into two equal parts, and since we have AB as 6, then one of this length here is going to be 3 centimeters. Likewise here, also 3 centimeters, and the hypotenuse is 5 centimeters, and this is meeting at right angle. So we can move on and take any of these sides here to calculate the height h. H will be calculated from the square of the hypotenuse, that is minus 3 square. So our h square is equivalent of 25 minus 9. Now when we subtract 9 away from 25, we get 16, and we get square root on both sides. And since we're dealing with only length, then we may focus on the positive root only. Therefore, the square root of h square is h, and the square root of 16 is either positive or negative 4, and this implies that h is 4 centimeters. Now since I've already gotten the height, then we can move on to get the area. Here, same area is given by a half times the base of the triangle AB times the height of the triangle, and here we can make substitution, and we have 1/2 times the base AB, and that is 6, and times the height, so I've just gotten here, that is 4, and we can move on to reduce these 2 by also 2 here to 3, and our area of the isosceles is also 12 square centimeters as before. So these are the two ways in which we can calculate the area of this isosceles triangle. If you have gotten some value from this video, consider subscribing to the channel in order for you to get notification for my upcoming videos, and see you in the next video. Peace out.